Okay, so welcome back, my dear friends. Let's continue with the exercise 5.5 NCERT Mathematics class 12. Okay, so differentiation based on logarithmic application. So since we have already studied in the previous classes what are the applications of log, but before we really begin, let's just write down some more formulas of log u by v, log u into v, and so on. So I'll just write here, you can note down those two, like log u into v. The application was log of u plus log of v. Both these applications we are going to be needing here. This was the first one. The second one was log of u by v as log of u minus log of v, and then of course we have another application, that is log of x power n in the exponent, then it will be n into log of x. So these were some of the applications which we were about to use. Take the help of logarithm, taking the help of logarithm to solve differentiation, to make our differentiation of complex functions more easier. Okay, so that's what we are going to use. I hope that you've noted it down. Let me run it off then. Alright, so now before we really begin, see this kind of functions, if we differentiate directly, then it might get a bit too messy. It's possible, but it might get a bit too messy. Okay, so what we will do is, like, I'll take the help of logarithm here, that is taking log on both sides. I'll just write down, that is like taking logarithm on both sides. So that will be log of y is equal to log of, now this is square root of a function that I will write it in the exponent form, that is x minus 2, x minus 3, x minus 4, x minus 5, whole power 1 by 2. We know that, isn't it? Because root of x is nothing but x power 1 by 2. Cube root of x is x power 1 by 3. So I've just transformed this root into whole power 1 by 2. Okay, so nothing much done there. Now, I will apply that third application of log, which I believe you have written it down, that is this side. I will let it be as it is, log y. Now log of x power n, so that's like n log x, so that's going to be 1 by 2 log of, it's okay, I will just write down, no problem with the mathematics, it's okay even if you write down steps, it's actually better if you write down more, especially for learners, it's always better if you just write down all the steps, because that makes your job much easier. Of course, slowly you can reduce the steps, but when you're a beginner, then okay, write down the steps, begin slow, and move about it steadily. Okay. Alright, so now let's continuing. So that will be again log of y. I'll keep it as it is. Now if you remember, I gave you the formula of log u by v. That was log of, I think this is done. I hope you have written it down. So log of u by v. I give you the formula, that is log of u by v would be like log of u minus log of v. So I'll first apply that. So that's going to be log of u keep this 1 by 2 common, okay, minus log of v, that is x minus 3, x minus 4, x minus 5, whole bracket, alright. And again, next step, log of y equal to 1 by 2. Now again, that formula, log of m into n, that will be log of m plus log n. So log of m plus log n minus, this will be, I'll do this directly, log of m plus into minus becomes minus log of x minus 4, again plus, but plus into minus again becomes minus log of x minus 5. I still haven't started differentiation yet. Okay, I'm planning to use differentiation, but let logarithm simplify our problem a little bit. Then I think we can still apply log because it's already now simplified. Everything is like completely broken apart. So let's differentiate. So now I'm not going to write down. So differentiating both sides with respect to x. That will imply differentiation of implicit functions. Again, differentiation of log y will be 1 by y. The residue will come up, that is del y by del x. Since it cannot be solved completely now. This is going to get a little bit lengthy because I'm going to write down all the steps one after the other just for you people. So differentiation of chain rule again. So differentiation of log x is 1 by x. But what is the function here? It's not x, it's like x minus 1. So I have to proceed with chain function, chain rule, that is differentiation of x minus 1. Similarly, log of x minus 2, 1 by 2, again differentiation of chain rule, x minus 2, okay, it's going to get very lengthy, anyway, no problem. 1 by x minus 3, differentiation of x minus 3, minus, again differentiation of log x minus 4 will be 1 by x minus 4, differentiation of x minus 4 minus 1 by x minus 5, differentiation of x minus 5. Okay, I believe that's fine. So now, that's going to be 1 by y. Okay, I'll just multiply y on the other side. So that's going to be y by 2. No, y you're taking it up. Okay, this one, x minus 1. So now differentiation of x. What will be differentiation of x? Differentiation of x is going to be 1, right? Differentiation of 1 is going to be 0 plus 1 by x minus 2. Again, differentiation of x, 1, differentiation of 2, constant 0, minus 1 by x minus 3, same thing here, 1 minus 0. Constant, you know that the derivative of constant is always 0, isn't it? 1 by x minus 4, derivative of x, 1 minus 0, minus 1 by x minus 5, differentiation of x, 1 minus 5, differentiation of 5, that is 0. So ultimately, if we just write it in the proper order, then that will be del y by del x. 1 by 2, what was the value of y? Y value was from the question x minus 1, x minus 2 whole root over x minus 3 minus 4 minus 5 into this value. Now since like 1 minus 0 is 1, 1 minus 0 is 1 into 1, that will be just 1, so that will be 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4. And finally 1 by x minus 5. That will be the derivative of that function which we started with question number 2. So nothing much done here. Nothing much done here actually. In the beginning it was looking like a very complex function, but that was simplified. Just taking the help of logarithm, we simplified the function which was looking very complex, and then taking the help of logarithm we simplified the function, and then finally we start differentiating, and then we end up like getting a more simplified function. So there the differentiation becomes a lot easier for us. Okay, now moving on, let's just move on to another question. Yes, we can help ourselves with one more question to banta hai na. Let's try, okay, this function, like question number 3 also. Let's try that. Y be the function that is given to us, that is log x whole power cos x. Okay, log x whole power cos x. Now this we cannot differentiate. We're not supposed to differentiate directly because see, again, like we have derivative of x power n, that's like x power n, where n is maybe any integer, so n into x power n minus 1. Then of course we have derivative of a power x, where a is any arbitrary constant, x is a variable, that is like ax into log a. But we don't have so far like x power x ka derivative too, we don't have na x power x derivative and all. This looks like function power x, isn't it? Exponent function power x, function power x. So now here, log will make our job very easy for us. That is, again, by taking, I'll not write again, no? By taking logarithm on both sides. By taking logarithm on both sides, what am I getting? Log y equal to log x cos x, no, this function, no, log of this function. So log of this function, log x cos x. Now, log y, remember the function that I gave you, that is log of x power n, that is n into log x. So I'm going to apply that is x ko yahan lana hai, that is cos x log of log x. Alright, I think now we are ready for differentiating, because I think beyond this we cannot simplify it further. So now differentiating, so that will become 1 by y with respect to x. Now this one here I shall apply product rule, that is u into v. So what was the product rule? That is differentiation of the, I'll write again, no problem. That is differentiation of u into v was u into derivative of the second function plus v into derivative of the first function. That's up to you. Reverse order maybe le sakte ho. So that's going to be like cos x derivative of log x. I'll just rub that part. Okay, I hope you've written it down. Shall I? Okay. Plus log x derivative of cos x. So, okay, one more step, all right, del y, then x equal to cos x. Now, derivative of log x. No? What is the derivative of log x? Here also we have to apply chain rule, because x with respect to x. So, the derivative of log x is 1 by x, but here our value, our function is not x, it's log x. So, that will be 1 by log x into the chain rule that we apply. Since we've already studied chain rule, I'm not stressing much on the application of chain rule here. I believe that you are already aware of the chain rule. That now what is the derivative of cos x equals minus of sin x. Chalo. Then let's continue. Isko rub kare. Okay. Then okay. Y, I shall write up there, cross multiplying. I have cos x by log x. Derivative of log x is 1 by x plus into minus, that becomes minus sin x log of log x. Now y value, if you want, you can substitute it back here. That is log x cos x, wasn't it? Yeah, log x cos x divided by cos x log x minus sin x log of log x. I believe it can be simplified in that form. So that is how we can apply logarithm, make our questions much easier. So logarithm is like not a new formula for differentiation and all. It's just a tool that we're using. Logarithm is just a tool that we're actually using to help us simplify differentiation. Help us get the derivatives of more complex functions with the help of taking the help of logarithm. Okay, so I hope you have liked what I've done here. So if you have liked what I've done here, please do subscribe to my channel so that you will get notifications to more solutions that I will be doing now henceforth with all the syllabus, the entire textbook. I'll be solving all the entire textbooks. Okay, so please do subscribe so that you can get notifications, and if you have liked what I've done here, please do hit the like button. Thank you.